Welcome back. In the last class, we have seen what is periodic table and what are the parts of the periodic table, that is, what is group, what is period, and also we have seen one particular periodic property, that is atomic size. Just to refresh, if you want to tell it in a single line, what exactly happens to the atomic size in a periodic table? It increases down the group. That is, when you go from hydrogen to francium, atomic size increases. The reason being addition of new shells, addition of electrons into the new shell in every step here. But as you go from hydrogen to this side, that is from, for example, I take lithium to neon, from left side of the periodic table to the right side of the periodic table, the size decreases. That is being the electrons added to the same shell, the number of electrons in the shell increases, hence electrostatic attraction increases, size decreases. So in single word, down the group atomic size increases, along the period atomic size decreases from left to right. Now let's come to the next topic. Here, this is just an example. You see, hydrogen is such a small atom, and a nucleus such a small atom, and cesium is the bigger. That is, down the group size increases, as we can see here. And you see here, lithium is the leftmost element in a group, this particular period, second period, and neon is the rightmost. You can see here the size decreases, and it is the atomic radius value they have given here in Armstrong. It's in picometer, 152 picometer to 70 picometer. You can see it decreases from 150 to 70 when you go down the when you go along the period. When you go down the group, it is increases from 37 picometer. You know, picometer is 10 to the power minus 12 meter is the picometer. 37 to 265, enormous increase, almost close to 8 to 9 times increase happens, which is clearly due to addition of electron to the new shell. Here it is, as I explained again and again in the previous, and here the decrease in the size happens due to addition of electron to the same shell. So I think this is clear, because why I'm telling this again and again, because based on this concept we are going to explain ionization energy, electron affinity, and also electronegativity, and also the metallic behavior and non-metallic behavior, which are quite important when you go to the concepts like metallurgy, concepts like chemical bonding. When you're studying ionic and covalent bonding, these concepts will be extremely important. That's why understanding why the atomic size varies in both electrostatic way and also in a chemistry way is quite important. So I think this concept of atomic size and why it varies is clear. Now let's see what is ionization potential. As the name suggests, ionization potential, this is the production of ions. Ionization. What are ions? Ions are charged species. Charged species. The formation of ions is the ionization potential. Here we are talking only about positively charged species. When you go to the electron affinity, we will talk negatively charged species. You know, a charged species is called as ion, and a positively charged species is called cation. A negatively charged species is called anion, right? In the ionization potential, to understand ionization potential, you have to understand what is ion. If we have an atom X, I will add an electron to that atom. We know number of protons is equals to number of electrons. Hence we have a neutral species. But when I add an electron to this particular element or to this particular atom, I am increasing electron concentration. You know, electron is positive and proton is negative. Now I am increasing the electron concentration or electron density. Hence I am increasing the negative charge density. Hence I have a negative ion, which is also known as anion. Similar way, I have an atom X, I will remove an electron. When I remove electron, the electron density decreases, the proton remains same. Hence we have 10 protons and 10 electrons. I remove one electron. Now there are 10 proton, 9 electrons. So number of proton is more. I can say it is a positively charged nucleus. Positively charged atom, or known as cation. The formation of cation is the one which we learn in the ionization energy. I hope now it is clear. The formation of cation, that is removal of electron, is the one which we are talking in the ionization energy. So what is ionization energy? We know when we remove an electron, we will form a cation. But to remove that electron, we need energy, because previously we have seen there is an electrostatic interaction Q1 Q2 by R square. Q1 Q2 by R square. We know there is an electrostatic interaction between the nucleus and the electron. So to remove the electron from here, we have to overcome this particular energy. So we have to apply some energy. The energy which is applied to remove the outermost electron. Generally, in a standard definition, we say the remove the outermost electron in a gaseous atom. That energy is known as ionization potential or ionization energy. Just repeat. Ionization energy. What it is? The energy required to remove the outermost electron of a gaseous atom. That is, you have to overcome this particular energy. There is a electrostatic energy, as I told, Q1 Q2 by R square. You have to apply a certain energy and remove that electron, this electron. Since if you want to link this to thermodynamics, see here nucleus, here there is electron. You are putting some energy and removing that electron. Hence, you are spending the energy. So work is done by yourself on this one. Hence, you can call it as endothermic process. That is, energy is needed. It's not energy released in this process. Energy is taken up in this process. That is, you have to put some energy, remove that electron. Hence, formation of an ion, that is cation. Keep it in mind. Formation of a cation is an endothermic process. That is, you have to spend energy. The energy which is spent is known as ionization potential. Now let's see what are the trends of ionization potential. As now I think the concept is clear. So you can try it yourself. I'll give us 5-6 seconds. Try yourself. What might be the trend in the periodic table? You know what is the ionization potential? That is, you need the energy needed to remove the outermost electron, and the energy needed to remove outermost electron. That means you have to overcome the attraction between nucleus and electron, and you know that attraction is electrostatic and depends on this charge and distance. And you know what is the size of a nucleus, how the size varies. Can you try to correlate? Okay. I think you have tried, or you can pause the video and try yourself. Can you do it? Can you predict the most of you, I think you have predicted right. As the size increases, as we have seen here, electron was here first in the first this particular one, in first hydrogen for example, then electron in lithium is here, sodium here, goes on increases. So is going away and away. As you know, the R square or the R increases, the distance increases, the static interaction decreases. If there is less interaction, we can remove it easier, right? See, there is a you have a there is a magnet. You have a magnet here, you have a magnet here. When the magnet comes closer, there will be attraction, more attraction. When you take away and away, the attraction is leaves, and at a certain point there will be no attraction between the magnet. Same way, so you can move that magnet very easily. But when they're close, moving the magnet is difficult. Same way, when the electron is closer to the nucleus, removing it, you have to apply more energy. That is, you have to move the magnet with force, if I consider that analogy. But when the electron is far away, you can remove them quite easily. Hence, down the group, as the size increases, it follows exactly the pattern of size. As the size increases, ionization energy decreases here. Why the ionization energy decreases? Because as the size increases, electron is farther away, you can easily remove it, so you have to put less energy. So if I had to write that in one word, I'll put it here. Size of atom increases, the ionization potential or ionization energy decreases, and vice versa, right? As the size decreases, ionization energy decreases. That is the case here. Why it happens so? Again, we have to go back to this particular equation. Here the size is same. Now R square is same, because as we have seen previously exhaustively, here R is same because you are in the same shell, but you are adding electron to it. Hence, there is some more attraction, electrostatic, because Q2 is increasing. Let's say Q2 is the electron density. Q2 is going on increasing. You are attracting, you are pulling the electron towards. Since it is attracting more, you are pulling the electron towards it, towards the nucleus. The attraction increases. Since attraction is more, removal of that electron from the outermost shell is extremely difficult. Hence, the more you have to put more and more energy. Hence, when you go from left to right, the size decrease, Since size is smaller, the attraction is more, you have to put more energy to remove that electron. So if you put it in here, as the size increases, the ionization potential, I'll write it as IP, increases. So let's write it like size and IP. Okay, as the size increases, as you know, listen carefully, as the size, it's just a revision, as the size increases, the distance between the nucleus and outermost electron decreases. Hence, electrostatic attraction decreases. You need less energy to remove the electron. So, ionization potential decreases. But as the size decreases, electron is coming closer and closer, or electron is much nearer to the nucleus. Hence, you have to spend more energy, and hence, electroionization potential increases. This is one important concept you have to remember. Once you remove the electron, ion you obtain is known as cation. Okay, it is cation. Okay, and it depends on one more factor. Now we have seen the effect of size. It is also depending on charge. That is, now for example, you have sodium, and you have removed one electron and found sodium plus. Now you have to remove next electron. Now removing next electron becomes difficult because you have, there is a proton, there is electron. Now number of electrons have been decreased, so the balance is towards proton. Now proton started attracting more and more strongly than it was previous. Hence removal of next electrons becomes quite difficult. And next, hence the first ionization energy, that is removal of one electron, is much easier than second ionization energy, than third ionization energy. Hence, in a simple way, as the charge, that is positive charge on the atom, that is will form the ion after formation of ion, as the charge increases, ionization potential increases, because as the charge increases, the attraction towards the electron increases, because the protons are more and they start pulling each other much closer, and hence the ionization potential increases. So this is the relation between size and charge. As the size, for the size, as the size increase, IP decrease. As the size decrease, IP increase. And as the charge increase, IP increase. This is for cations. Ionization potential is for cations. Let's go to anions. What happens to anions? In case of anion, how anion is formed? You take an atom, give it electron. Why an, see, we'll discuss this in the chemical bonding. Why an atom want to lose electron? Why don't want electron? Because there should be some energetics. See, in a whole nature, all the elements, all atom wants to be stable by whatever the way they want. Hence, this is energy. This will be always, nature always follows energy efficient process. That is, they want to be stable by losing energy. They want to leave energy and they want to become stable. And why they form positive and negative ions, we shall discuss in the atomic bonding. For now, in an ion, you give an electron, it forms a negative charge, because it has strong motive to take that negative charge, because then it will be stable. Now, when you add an electron to the atom, that is gaseous atom, you add an electron, some energy is released. The energy which is released is electron affinity. That is, what is electron affinity? The energy released when an electron is added to the outermost orbital of a gaseous atom. That is electron affinity. See, in the name itself, there is a thing, electron and affinity. There are two words. Affinity towards electron, love towards electron is the electron affinity. How much it wants to take the electron, that much energy is kept on releasing. That is the electron affinity. So, this is just opposite of ionization potential in terms of definition. Ionization potential, the amount of energy released when you remove the electron. But the electron affinity is amount of energy, sorry, ionization energy is the amount of energy you have to put it in to remove the electron. The amount of energy you have to put to remove the electron. But electron affinity is the amount of energy released when you add an electron. So in a periodic table, what happens? Now let's see what is the effect of size on this. When here we have an electron here and we have here. See, now adding electron, when this is closer to nucleus, this is farther to nucleus, this is farther to nucleus. You know, there is will be electrons incoming and there will be already electron. Electrons are negative species, both the incoming, the electron present. Hence they will repel. You know, like charges repel and like charges attract. So when they are closer to nucleus, nucleus can have its effect and attract the incoming nucleus, and hence there will be more electron affinity. The affinity towards electron is more, hence energy release will be more. But in the case of larger nucleus, it is farther. The outermost orbital or outermost electrons are farther. When the electron comes, the effect of nucleus will be lesser, but effect of outermost electron which is already present will be more. Hence, any electron incoming will face a strong repulsion by the electron already present in it, rather than facing a strong attraction by the nucleus. Hence, as the size increases, the repulsive force of the nucleus, which is repulsive force of the electron which is already present, increases, and hence electron affinity decreases. For a common understanding, you can think as the similar to the ionization potential, but concept is different. As the size increases, electron affinity decreases, and as the size decreases, electron affinity increases. So this is about the periodic table, and here as we go down the group, electron affinity decreases because size is increasing. The francium, the electron, outermost electron is very far away, here almost. Let's think. When the electron, another electron comes, the nucleus is much away, but here there is already electron. That electron start repelling the incoming electron, and hence that putting that electron there is not very feasible. Hence it does not want an electron in itself. Hence the electron affinity is less. But when you come to fluorine, this one, the size of the fluorine, as we know, it is smaller, very smallest to be this one, because as you go here, the size is much smaller. Hence for fluorine, the electron is almost here. Okay, then when the new electron comes, of course there will be a repulsion from this particular electron, but the nucleus is, since the nucleus is much closer, it exerts its pull towards it, because nucleus is much more massive than an electron. Hence it exerts its pull towards that incoming electron. Hence the repulsion caused by the electron which is already present will be balanced, and hence the electron affinity increases. That is, love towards electron increases, and that is the energy released will be more. So to summarize, all the three key factors, I'll put it in one particular slide. I'll make a small table: size, ionization potential, and electron affinity. Okay, as the size increases, ionization potential decreases and electron affinity decreases. As the size decreases, ionization potential increases, electron affinity decreases. And if you write a rough periodic table down the group, what happens? Size will increase, and hence ionization potential decrease, electron affinity decrease. When you go along the period from left to right, size will decrease because of addition of electron to the same orbital, same shell. Hence the energy, the interaction is more, removal of electron is difficult, ionization potential increases, and also the size is smaller, electrons are, outermost electron is closer to the nucleus, the addition of a new electron is easier, and hence electron affinity increases. So when the concept of ionization energy comes, you are talking about a positive charge or cation. When the concept of electron affinity comes, you are talking about negative charge or anion. Okay, these are the three major concepts in the periodic table. There is one more concept, electronegativity, which we shall see in the topic of chemical bonding, or more importantly in the concept of covalent bonding. And there are two more characters, metallic and non-metallic behavior. As I explained in the previous periodic table example, let me take a different color here. these are metals. What are and these are non-metals. Why? What is the distinction between metals and non-metals? The distinction is metals are the one which can lose the electron easily, and non-metals are the one which can gain the electron easily. Losing the electron easily means, yes, lower ionization potential. You know, in a periodic table, these two have lower ionization potential, because you know ionization potential increases this way. So obviously these have the lower ionization potential. Hence, the elements which are able to form readily lose the electron and able to form the cations are metals, and which gain the electron and readily form the anion are generally referred as non-metal. And you know, electron affinity also increases from left to right. That is, towards the far right, you have high electron affinity. That means the ability to attract electron is higher. Hence, you have a non-metals on the right side of the periodic table, and you have metals on the far left side of the periodic table. And this is about general metallic and non-metallic behavior. We shall see this when you go to the chemical bonding, where when we see ionic and covalent interactions, we shall see how these metals and non-metal can be further explained and understood. So in general, to conclude the topic of periodic table, these are the main three important concepts. The first, what is periodic table? Where this arrangement according to their property, you have arranged them. That is first thing. You have four blocks: S, P, D, and F. Four blocks. Periodic elements are arranged in periodic table, and three major properties of those elements which can be explained by seeing the periodic table. The trend can be explained by seeing the periodic table. That is, size of the element, ionization potential of the element, that is ability to remove the electron or energy released when the electron is removed, and third property is electron affinity, that is the amount of energy released when the electron is added. That is, IP is the amount of energy you have to put in, that is you have to remove the electron. Here amount of energy is released because you are putting in an electron. Okay, these are the three major properties, and these are their trends. If you understand these trends, then you can study how the chemical bonding is formed, and also other different parameters, like what is the strength of cation, what is strength of anion. The strength of anion and cation is quite important when you come to the acid base concepts. So the periodic table is a gateway to understanding chemistry. I hope this concept is quite clear for you. Revise it, try to rewatch if you want. Thank you. We shall see in the next class.